greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about atmospheric pressure belt. In this lecture, we will be discussing about planetary winds. So, what are all the contents we are going to discuss in this planetary winds? That is, what is the nature and characteristics of planetary winds? What are all the three main system, that is trade winds, westerlies, polar easterlies, and what are all the factors which are affecting the planetary winds, and what is the three cell circulation model, that is Hadley cell, Ferrel cell, polar cell, and how planetary winds shaping the global climate and weather patterns. So, these are all the contents we are going to discuss in today's lecture. So, what is meant by planetary winds? The planetary winds are also called as primary winds, prevailing winds, permanent winds, invariable winds, because the wind is blowing in same direction throughout the year. So, because of this, it is known as primary winds, prevailing winds and permanent winds, and it is also invariable and it is evolving global level. Because of that, it is also known as planetary winds as well as invariable winds. Due to these characteristics, these winds are called in these names. Planetary winds blows extensively over continents and oceans. It is not stopping with one region, it is flowing throughout the globe, both in continents as well as in ocean region. The two most significant winds for climate and human activities are trade winds and then the westerlies. So, why these two major winds are most influenced by human as well as climate? Because in these latitudes only the human being have more inhabited. So, because of this, these two major winds are most important. The polar easterly winds impact less because the larger area is uninhabited. So, because of uninhabited, this polar easterly winds impact is comparatively less. The planetary winds are permanent large scale wind systems. So, because of that only this wind is also known as permanent winds. So, they originate unequal heating between equator and poles. So, we know that the heating process is not same in all latitudes. So, the intense heat will be near the equator region and there will be a less heating comparatively in the polar region. Because of the differential heating, so this kind of wind originates. So, they follow the nearly fixed global pattern. It is not like a local wind, that is the land and sea breeze. It have the fixed pattern. So, if it is going, it is flowing from northwest to southeast, means it is flowing in the similar direction throughout the year. So, it have a fixed pattern. And these winds redistributes heat and moisture worldwide. As it is blowing throughout the globe, it have a major influence in the redistributing of heat and also the moisture. The major planetary winds are trade winds, westerlies and polar easterlies. So, we will be discussing about these three winds in details. Trade wind, that is the trade winds are blowing from subtropical high pressure area towards the equatorial low pressure belt. So, in this region you can witness the trade winds from subtropical high pressure region towards the equatorial low pressure region, not in only one hemisphere, in both the hemisphere these winds are flowing. So, it is confined to the regions of between that is 30° north and south, that is hemispheres throughout the earth's surface. So, it is confined to this region. So, the trade winds have confined to 30° north and 30° south hemispheres. They flow as a northeastern trade winds in the northern hemisphere. See here you have northeastern trade winds and southeastern trade wind in the southern hemisphere. it also deflects in direction. So, it is most interesting to note that if the wind is going to be blowing from one region to another region, it might be in a vertical transformation, but this wind is not similar like that. Why? It is because of what reason? It is because of the Coriolis force and Ferrel's law. This Coriolis force and Ferrel's law makes this wind to divert, makes this wind to deflect and turn its direction in this region. So, this is the major reason for the deflection of this trade winds, not only trade winds, all the winds which is flowing in throughout the global spaces. It is a descending and stable in the areas of origin. Where this wind is originated? It is originated from subtropical high pressure belt region. So, in the atmospheric pressure belts, we have discussed about subtropical high pressure belt. So, from that high pressure belt, these winds are blowing towards the equatorial low pressure belt from both the hemispheres. It as they reaches the equator, they become humid and warmer after they pick the moisture on their way. So, from here what happens? So, from here it is blowing from subtropical towards the equatorial low pressure region. On their way it is gathering the moisture, and then in this region what it's giving a plenty of rain here. The moisture, that is the wind, has the moisture content, it carries from the way along and it is giving precipitation in this equatorial region. The wind converge at the ITCZ zone, that is intertropical convergence zone. So, here you can see the arrow mark indicating that it is converging, it is meeting together in this equatorial low pressure, that is ITCZ zone. The winds have produced the heavy rainfall and frequent thunderstorm. So, here because of intense heating and the cool moisture air which is coming from the subtropical high pressure. So, what happens here? This region receives the heavy rain and thunderstorms. The trade winds also meet in the equatorial low pressure belt. Due to the convergence, they rise and cause the heavy rain in this region. And in the eastern part of the trade winds, it is associated with the cool ocean currents which have the characteristics of drier and more stable. The wind which is the ocean current which is blowing here is very drier and more stable in nature than the ocean region. So, they drive major surface ocean currents and shapes the tropical climatic condition. So, the tropical climatic condition provides because of this trade winds. So, the trade winds plays a vital role in determining the tropical climate region. Characteristics of trade wind, that is it is very steady and predictable. What is predicted? That is the speed of the wind and direction of the wind is predicted. It transports warm moisture laden air from ocean towards the continent. So, it is transferring from ocean towards the continent. So, because of that, the air will contain what? The wind will contain moisture. So, that moisture which leads to the tropical rainfall, that is tropical rainfall and monsoon circulation is because of this trade winds. It drives the major ocean currents such as north and south equatorial currents are flowing because of this trade winds. It is most important for the early maritime navigation, the name trade. So, the trade activity in the ancient time happened in these belts. So, this wind supports the merchants to travel and transfer the goods from one place to another via the ocean. So, this trade wind plays a vital role in the maritime navigation. Westerlies. The next wind is westerlies, that is it blows from subtropical high pressure belt towards the subpolar low pressure belt, that is subtropical high pressure belt. Here you have subtropical high pressure belt and it is blowing towards the subpolar low pressure belt. here also in the southern hemisphere from subtropical high towards the subpolar low pressure belts. They blows from southwest to northeast. The direction in geography is most important. That is, this wind blows from here, it's southwest to northeast in northern hemisphere. And again here in the southern hemisphere, what is the situation? In the southern hemisphere, the northwest to southeast. So here see, so the northwest region towards southeast, it's blowing, the wind is, the westerlies are blowing. The westerlies of southern hemisphere is stronger and persistent. Why it is stronger and persistent? It's because of vast expanse of water. So, you know that the northern hemisphere, most of the continents land masses are covered in the compared to the southern hemisphere. So, because of vast water bodies, this wind is very much strong in southern hemisphere. Because of uneven relief of vast and land masses in the northern hemisphere, it is not that much strong. That is, the westerly is not that much strong in northern hemisphere compared to the southern hemisphere. The westerlies are best developed in 40° north to 65° south. So, that is the 45° to 65, you have this westerly winds. It is also called as roaring 40s, furious 50s, shrieking 60s. Why? Because this wind is very much roaring like lion, and it is very much furious, it is very much gusty, it is very much strong. So, it is known as a furious 50s, and shrieking 60s, it is very much noisy in nature. So, because of this noise and gusty wind, this westerly is named after roaring 40s, furious 50s and shrieking 60s in this region. That is a prevailing westerlies is termed as these names. The poleward boundary of westerly is highly fluctuated. So, why there is a fluctuation in poleward? It is because of it is also seasonal and short term. It is because of jet streams. So, we know that here there will be a jet stream. So, because of that, it is very seasonal also. So, because of this characteristics, it is very much highly fluctuated in this region. The characteristics of westerlies. What is the characteristics of westerlies? That is, it dominate in the mid latitudes. So, it is prevailing in the mid latitude region, and the speed and directions due to frequent cyclones. It varies, that is, the speed and direction of this westerlies varies because of this cyclone activities. Transport the moist air from ocean to higher latitudes. So, the moist air is transported from the subtropical high pressure to the higher regions. It is transporting, the wind is transported, and the strong influence of rainfall pattern over Europe, North America and South Australia is mainly influenced by this westerlies. So, these countries have been much influenced by westerly winds. The upper level of westerly gives rise to jet streams. So, in the previous slide we have discussed. So, when it travels in the higher latitudes, it gives rise to the jet streams. The wind will be very much gusty in that particular latitudes. It is mainly significant because of redistributing heat and energy across latitudes. So, the redistribution of heat across the latitudes plays an important role because of this westerly winds. Why it plays an important role in tricircular cellular pattern, we will be discussing this one in detail. Next one is polar easterlies. So, polar easterlies is in the polar region, that is the polar easterlies here, which is blowing from northeast to southwest region. So, from northeast to southwest region, this polar easterly wind is blowing in both the hemisphere, and in the southern hemisphere it is from southeast to northwest. So, southeast to northwest this wind is blowing. So, they blow from polar high pressure areas towards the subpolar low pressure area. See, you have the polar high pressure area here, and subpolar low pressure area here. So, the wind is blowing from northeast direction towards the southwestern direction in the northern hemisphere, and then in the southern hemisphere what is the situation? In the southern hemisphere, the wind blows from the southeastern region towards the northwestern direction. Polar Easterlies. The polar easterlies are dry, cold, prevailing winds which blows from the northeastern direction to the southwestern direction. So, the northeastern direction to the southwestern direction in the northern hemisphere, and then in the southern hemisphere what is the situation? That is, it blows from southeastern direction towards the northwestern direction. So, this was the condition of the polar easterlies wind, and they blow from polar high pressure area to subpolar low pressure area. So, this is the polar high pressure region. So, from the polar high pressure region, it is blowing towards the subpolar low pressure region. So, the wind is descending from the polar high pressure towards the subpolar low pressure region. What are the factors which influences the planetary winds? That is, the uneven heating of Earth's surface, which is created in each and every belts. How the wind usually travels? The wind usually travels from high pressure towards the low pressure region. So, this blow is because of uneven heating of Earth's surface, and because of earth rotation, that is, because of earth rotation, the Coriolis force. So, this Coriolis force deflect the wind from the straight path. The wind is not traveling straight, it is deflecting. So, because of this Coriolis force, the pressure gradients, that is the pressure gradient force which drives the air from high pressure belts towards the low pressure belts. So, this pressure PGF is nothing but it is a force. This force exerts in the wind, which always most probably the wind will be traveling because of this PGF from high pressure region towards the low pressure region. The surface friction alters the wind speed and direction. So, because of the surface friction, so a few meters from the earth's surface, the friction force is there. So, because of this friction, there is a wind direction and speed also changes near the land surface as well as the ocean bodies. The seasonal movement of sun caused the slight latitudinal shift in the wind belt. So, in the previous lecture we have discussed about the shifting of the latitudes, shifting of the atmospheric pressure. So, there is a slight shift. So, that shift is also one of the major factor which influences the planetary winds. Tricellular circulation. So, the wind is not only circulating in the horizontal movement, that is in the latitudes, it is also blowing vertically, that is the longitudinal pattern also the wind is circulating. So, how it is circulated? That is, the wind belt gliding the planet are organized in 3 cells in both the hemisphere. So, you can see the 3 cells, this is cell 1, 2, 3. Here also the cell 1, 2, 3. So, in the both the hemisphere you have a tricellular 3 cells here, which have been the wind circulated in this 3 cells. That is, the first cell is Hadley cell, it is also known as tropical cell. The second cell is Ferrel cell, it is also known as mid latitude cell, and third one is polar cell. So, this 3 cells which plays a vital role in the vertical movement of the wind. Hadley cell, the first cell, the air at this intertropical convergence zone, that is ITCZ, rises because of what? Because of convection. So, due to heat, due to high insolation, the air rises, the convection process happens in the ITCZ zone. So, because of that, the high insolation and low pressure is created in this belt. So, in this belt, the ITCZ, this Hadley cell have the high insolation as well as the low pressure region. So, because of this characteristics, what happened? Because of this, the wind from the tropic converge at the low pressure zone. So, this is the low pressure zone. So, in the see here, the wind from the subtropical region, it is converging towards the equator. So, in the both the hemisphere, it is converging. This is because of the intense heating and convection process. This converged air rise along with the convection cells. So, because of this, there is a convectional cells processes happening in this zone. It reaches the altitude of 14 kilometers and moves towards the pole. So, after reaching the equatorial low pressure, what happened? This air come here because of heating in this zone. Again, due to convection, the air rises to the subtropical high pressure zone. So, because of rising air, from which kilometer till the distance of 14 kilometer it is rising, and then some air will be descending because of it is cooling here, it will descend back here again, and some air will be escaping towards the polar region. So, this process is known as the Hadley cell circulation. This entire process causes the accumulation of air about 30 degree north and south. So, this process is happening from 0 degree to 30 degree in both the hemisphere. So, here also you have Hadley cell, here also you have Hadley cell. So, this Hadley cell first cell region is happening till the 30 degree north and south latitudes. The part of air sinks to the ground and form the subtropical high pressure belt. So, part of the air, what happens here, it is sinking due to cooling nature, because of heaviness of air, it is sinking in the subtropical region. And then the zone here where the greatest heating is occurred, it is also known as thermal equator. So, this region is known as thermal equator region. So, the next cell is Ferrel cell, polar cell or mid latitude cell. So, in the middle latitude, the circulation is sinking, that is cold air is sinking in this region, that is Ferrel cell. So, why? That is the cold air from the polar region is sinking here, and then the warm air from the equatorial low is rising in this region. So, there is a sinking and rising which cause a cellular activity in this zone, that is in the mid latitude zone, which is known as Westerlies, and this cell is also known as Ferrel cell. The large part of the energy that drives the Ferrel cell is provided by the polar cells and Hadley cell circulation on both the sides. So, this cell is getting energy from Hadley cell and then polar cell. So, it is the midpoint of these two cells which is energized by this polar and equatorial low pressure region. The Ferrel cell is very weak and the air which flow and the temperature within it is variable. So, it is very weak zone. This mid latitude have sometimes known as mixing. So, we know that this mid latitude cell is called as a mixing zone. So, this mixing zone is provided in this Ferrel cell. That is at high altitude, the Ferrel cell overrides the Hadley and polar cells. So, in the higher altitude this was the case. Next one is the polar cell. At the polar latitude, the cold dense air, what happens? The cold dense air subsides. So, it is coming down and then blows towards the middle latitude as the polar easterlies is formed. So, because of that the polar easterlies is formed here and it is also called as polar cell. So, this cell is known as polar cell. So, in this cell, because of a heaviness of air, it sinks down and then the warm air from this subtropical zone again rise up. So, this circulation makes the polar cell. This polar cell is circulating at 60 degree latitude. The air rises to the tropopause. In the tropopause region, this air is rising and about 8 kilometers at the latitudes. It moves towards the polewards. So, the wind is moving towards the poleward again. So, this is cooled and is considerably denser than the underlying air. So, the underlying air is warmer, the polar air is colder. So, there is a process of sinking and rising of air in this cell, which collectively forms the polar cell. So, it descends, creating a cold, dry and high pressure area. So, here what we have? Polar high pressure region. Polar high pressure region we have in the both the poleward side. So, this is the main cause of this circulation cell. The next one is the air at the surface moves towards the equator, it deviates towards the west due to the Coriolis force. So, throughout the global level, this Coriolis force plays an important role in diverting the wind from higher region towards the lower region or lower region towards the higher region. The air flows at the surface is known as polar easterlies. So, this air is known as polar easterlies. The outflow of air mass cell creates the harmonic wave. This harmonic wave in the atmosphere is known as Rossby wave. So, this wave is in name of the Rossby. So, it is known as Rossby wave. The zonal overturning circulation. So, how the zonal overturning circulation happens? This Hadley cell, Ferrel cell and polar cell are the three major cells which have been evolving or flowing throughout the global surfaces. So, because of the heat transport, the heat plays a vital role in this circulation. So, it is not ideal, it is not independent. So, these three cells interconnected with one another and it have the circulation process. The temperature differences drive a set of circulation cells whose axis circulations are longitudinal oriented. So, in the earlier that is slide we have discussed that this cell movement is vertical movement, that is it is the longitudinal circulation. So, latitudinal circulation is different. Here the cellular circulation is longitudinally circulated the wind patterns. The atmospheric motion is known as zonal overturning circulation. So, the circulation of wind is not moving upward, that is vertical, it is moving up, rising up and falling down. So, this circular movement, it is turning movement is known as the zonal turning circulation. The warm air over the equator, continental and western Pacific regions are rising. This was the main cause for this zonal overturning circulation. In the tropopause region, the air cools and subsides. So, because of this zone, the zonal water is much cooler and it forms the zonal oceanic cell in this region. And the Pacific Ocean cell plays an important role in the Earth's weather. So, why it is playing an important role in the Earth weather? That is, the Pacific cell in such plays an important role because of this Walker circulation in the name of Sir Gilbert Walker. So, this Pacific Ocean which plays an important role in between the land and continent heating and cooling process. So, this plays an important role in determining Earth's weather patterns. Walker cell El Nino effect, that is the warming and cooling of the Pacific Ocean strongly influences the general atmospheric circulation. The El Nino occurs when warm Pacific water moves eastward and replaces the cold Peruvian current in the South America. So, because of this it results in the appearance of warm water along the coast of Peru. So, in the Peruvian coast there is a warm water because of this effect. The El Nino is affected with pressure changes between central Pacific and Australia, which is also known as southern oscillation. So, this both El Nino and southern oscillation is combinedly known as ENSO effect. So, this two El Nino as well as the southern oscillation plays an important role in the atmospheric circulation as well as determining the weather pattern. The importance of planetary wind, that is it redistributes the heat and moisture. It is not keeping with itself, so where there is a intense heat, it is transferring to the area which is deficit. So, this circulation is happening, this redistribution is happening because of this planetary winds. It drives the major weather system, and it also important to track the storms. It defines the global climatic zone as well as the rain pattern of the entire globe. It influences the agriculture, forest and marine ecosystem of the earth's surface. It also regulates ocean and atmospheric interaction and global circulation. To sum up with the entire lecture, that is, the planetary wind or permanent large scale wind which blows across the different latitudes of the earth. They are driven by global pressure belts, differential, because of differential heating between equator and poles. The rotation of earth's surface, Coriolis effect also plays an important role. The three main planetary wind system, that is trade winds, westerlies and polar easterlies, operated within the three cell circulation, that is Hadley, Ferrel and polar cells. Together these winds redistribute heat and moisture, and also it plays an important role in shaping global climate and weather patterns. Hope you understand the concept of planetary winds. So, in the upcoming lecture, we will be discussing about isobars and pressure gradient. Thank you.